Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Today we will start with section 1.2.3 with the title of Inequalities. Let's see first the integer number line. This line shows the numbers, especially integers. In the middle of this line, there is 0. 0 is neither positive nor negative. To the left of 0, we have the negative integers, and to the right of 0, we have the positive integers. Okay, so the negative integers will be -1, -2, -3, -4, and so on, until we reach to -infinity. And to the right, we have 1, 2, 3, 4, until we reach to positive infinity. But still, we have we have in between some other numbers, real numbers. So we have, in fact, many real numbers between 0 and 1, between 1 and 2. So we have to include these numbers as well, because we are dealing with all real numbers. Okay. So a number line can be used to decide whether or not one number is greater or less than another number. We say that a number A is greater than a number B if A lies to the right of B on the line. And we write this as A greater than B. So we use this symbol to describe the relation between A and B. So when we write this symbol, when we use this symbol, it means that we read it from left to right. We say A is greater than B. So which indicates that A lies to the right of B on the line. Likewise, we say that A is less than B if A lies to the left of B on the line. And we write this as A less than B. We use this symbol. See, these two symbols are different. The first one is for greater than, and the second symbol is for less than. From the diagram, we see that the number -2 is greater than -4. Why? Because -2 lies to the right of -4. This is equivalent to the statement -4 is less than -2, because if -2 is greater than -4, it means that -4 is less than -2. Similarly, when we say 0 is greater than -1, is equivalently, or it's equivalent to saying -1 is less than 0. Why? Because 0 lies to the right of -1. There are occasions when we would like the letters A and B to stand for mathematical expressions rather than actual numbers. In this situation, we sometimes use the symbols, this symbol, which means greater than or equal to. And the other symbol here, which means that less than or equal to, means the symbol is either greater than or equal to a number or less than or equal to another number. We have already seen that we can manipulate equations in any way we like, provided that we do the same thing to both sides of the equation. An obvious question to ask is whether this rule extends to inequalities. To answer this question, let us see the following example. Consider the true statement 1 less than 3. Adding 4 to both sides gives 5 less than 7, which is true. Adding -5 to both sides gives -4 less than -2, which is also true. Multiplying both sides of this inequality by 2 gives 2 less than 6, which is also true. However, multiplying both sides by minus 6 gives minus 6 less than minus 18, which is false. This indicates that the rule of manipulating equations needs modifying before we can extend it to inequalities, and that we must be careful when manipulating inequalities. We can see here from the above example that adding positive number or adding negative number or multiplying both sides by a positive number or even dividing both sides by a positive number will be correct, similar to the equation. However, if we multiply by a negative number or divide by a negative number, we have to do something here to make sure that our operation is correct. And to emphasize on this, let's start with this example. Let's see this statement. 6 is greater than 3. And we will decide which of the following operations are valid when performed on both sides of the inequality. If we add 6, let's add 6 to this inequality. So if we add 6, let me, okay. So I'm going to add 6 to both sides of this inequality. So if I add 6 plus 6, and this is 3 plus 6, so what I will get is 12 greater than 9, which is true. This is true. So adding a positive number like 6 to both sides of equation will lead to a true statement. This will still a true statement. Let's see if we multiply by 2. 2 is a positive number. So if I multiply 6 by 2 and also 3 by 2. So I am multiplying both sides by 2. So this will give us what? 12 greater than 6. Is this correct? Yes, correct. So this is also true. So multiplying by a positive number will lead to a true statement. It will not change the statement or the sense of the statement. Okay, let's subtract a positive number. So 6 minus 3, and here we have 3 minus 3. So we'll get a 3 greater than 0, which is also a true statement. Okay, how about adding minus 3? So adding minus 3 means subtracting a 3. So this will give us 3 greater than 0. So yeah. So subtracting a negative number or adding a negative number, subtracting a positive number or adding a negative number will lead to a true statement. Adding a positive number will lead to a true statement. Multiplying by a positive number leads to a true statement. Let's see if we divide by a positive number. So divide by a positive number also. So 6 divided by 3, and the right side will be 3 divided by 3. This gives us 2 greater than 1. Also, we have true statement. How about multiplying by a negative number? Let's see. Multiply 6 by minus 4, and the right side multiplied by minus 4. So what we will have, we have minus 24 greater than minus 12. Well, this is not a right statement. This is a wrong statement. Why? Because minus 24 is not greater than minus 12. minus 24 is less than minus 12. Why? Because it lies to the left of minus 12 on the line. So this statement is wrong. So multiplying by a negative number will make the statement, will change the sense of the statement. And to overcome this difficulty, what we will do is we will reverse the sign here, the sign of sense. So this operation is not correct. If we want to multiply by a negative number, then we have to do something. Okay, let's multiply by minus 1. So multiplying by minus 1. So in order to multiply by a negative number, then we have to do something. What is that? We have to reverse the sign. Which is minus 6 less than minus 3, which is correct because minus 6 is to the left of minus 3. So now the operation is correct. So see here, the sign of sense has been changed from greater than to less than. Same thing here. If we divide by minus 3, then we have to say 6 divided by minus 3. Then I have to reverse the sign, change it, instead of a greater than, less than. So this is 6 divided by minus 3 is minus 2, less than minus 1, which is correct. Minus 2 is less than minus 1 because minus 2 lies to the left of minus 1 on the line, on the number line, okay? So this is now becomes correct. So here f, for f, if we want to multiply by minus 4, and to get a true statement, we have to reverse the sign. So this is true. So always, you can do any mathematical operation in equality similar to the equation, except that if you are multiplying by a negative number or dividing by a negative number, you have to reverse the sign of sense. Adding minus 10 also is correct. So the previous examples show that the usual rules does apply to inequalities, except when both sides are multiplied or divided by a negative number, then the sense of the inequality is reversed. By this we mean that greater changes to less than, greater than sense will be changed to less than sense, and less than or equivalent should be changed to greater than or equivalent, and so on. Consider the following inequality. 2x plus 3 less than 4x plus 7. So we want to solve it, means we need to find the value or values of x that will satisfy this inequality. So similar to the equation, what we will do is I'm going to keep the x in one side and the numbers on the other side of the inequality, because we still can call this the left side of the inequality and this is the right side of the inequality, and we have the sign of sense here between them. So if we subtract minus 4 from both sides of this inequality, see 2x minus 4x plus 3 less than 4x plus 7 minus 4x. We said if we adding a negative number to both sides of the inequality, that is correct, will not change the sense of the inequality. then we will have 2x minus 4x, x is equivalent to minus 2x plus 3 less than 7, because 4x minus 4x in the right side cancel each other. Now we have to get rid of this 3, so we have to add minus 3, or we have to subtract minus 3 from both sides. Then we will get minus 2x less than 4. And then we need to keep only x in the left side, but x is multiplied by minus 2, so we have to divide by minus 2. Well, we said just now, if we divide by a negative number, we have to reverse the sign here. So this sign has to be changed. Instead of less than, change it to greater than. So when you divide by minus 2, you have to reverse the sign. Minus 2 will be cancelled with minus 2, and the remaining will be x is greater than 4 divided by minus 2 is minus 2. So here, the values of x that will satisfy the inequality is x greater than minus 2. See here, we don't have only one value of x similar to the equation, similar to the linear equation, but instead we have here a range, a set of values, a range of values. So any value of x greater than minus 2 will satisfy this inequality, will make the left side of this inequality less than the right side of this inequality. Here we have some practice problems, simplify the inequalities or solve the inequalities. Okay, 2x less than 3x plus 7. So we have to do the steps similar to the previous examples. So I will leave these practice problems for you. You can try at home, and we can discuss these problems during our class, inshallah. Thank you for today. I'll see you during the class. Bye-bye.